Good day, everyone. Welcome to the third week of second quarter. Let us start our lesson for today. Let's begin with an end in mind. Ano ang target learning competencies natin sa araw na ito? First, describe the changes in mineral components and texture of rocks due to change in pressure and temperature, which is about metamorphism. Second, describe how rocks behave under different types of stress, such as compression, pulling apart, and shear. Do not forget your portfolio entry for this week's lesson. First, you need to determine the definition, types, and factors of metamorphism. Second, you need to differentiate foliated and non-foliated metamorphic rocks. Third, you need to give the different types of stress, stages of deformation, types of deformation based on materials or rocks, and factors of deformation. Lastly, you have to determine the effects of differential stress to the rocks or to the rock techniques. Simulan natin sa pag-alam kung ano nga ba ang pinagkaiba ng stress at strain. Stress is known to be the force applied per unit area. So ito yung puwersa na na-apply sa mga bato. Samantalang ang strain, ito naman yung pagbabago na nararanasan ng bato dahil sa stress. This is the change in rocks due to different type of stress, and this is known also as the deformation per unit area. Kapag na-apply ka ng puwersa, that stress, to the rocks, those rocks may change their appearance, behavior, and that's what we call strain. Stress is measured in the unit Pascal. Again, that's Newton over meter squared, or force per unit area. However, strain is unitless. It is simply defined as the change in the rocks. Stress can exist without strain. Pwede may force na nag-act sa rocks. However, it may not change. Okay? Walang pagbabagong nangyayari sa bato. However, strain cannot exist without stress. For change to happen in the rocks, importante na may force na maa-apply dito. For the types of stress, we have uniform stress, also known as confining pressure, and we have differential stress. May tatlong klase: tensional, compressional, shear. For strain, there are different stages. May tinatawag tayong elastic deformation stage, ductile deformation stage, and fracture stage. At may dalawang klase rin ng strain. May brittle at merong ductile deformation. Pag-uusapan natin yan lahat in a while. Now, for the types of stress, we have what we call uniform stress. Dahil sa pangalan niyang uniform, ma-infer natin that the force acting on an object is uniform and equal in all directions. Another term for uniform stress is pressure. For differential stress, this happens if the force are not equal from all directions. So pag uniform, equal in all directions, pag differential stress, it is not equal. Under uniform stress, we have confining stress or pressure. This is the weight of overlying rocks that exert pressure. Yung mga nakapatong na bato, okay, tinutulak niya pa ibaba yung mga rocks na nasa ilalim. So yung downward na stress na yon ay tinatawag natin confining stress or pressure. This is an example of uniform stress. For differential stress, we have three types. First is tensional stress, where rocks are being pulled away from each other. They are being pulled apart. We have compressional stress. In this case, the rocks are being pushed together. Kaya nga sa compression. While shearing stress, the rocks are moving sideways with each other. They slide past each other. Alright? Ngayon, ano ang epekto nitong differential stress sa mga bato? First is that the rocks get deformed or nagkakaroon ng deformation. The deformation of rocks is also known as diastrophism. So makikita nyo sa picture A, before the stress is applied, iyan yung normal appearance ng rocks. Pag nagkaroon ng shearing stress sa letter B, makikita ninyo that the rocks are slipping past each other, nagkakaroon ng crack sa gitna. And that crack is what we call fault. Sa letter C, the rocks are being stretched, kaya yung bandang gitna ay numinipis hanggang sa unti-unting maghiwalay at mapitak yung bato. For compressional stress naman, makikita nyo na natutulak yung rocks papunta sa isa't isa at sa bandang gitna where these rocks meet, nagkakaroon ng pagbag or pag-angat ng lupa. So dito nagkakaroon ng tinatawag na folds. Ang deformation ay may iba't iba ring stages. Una, yung tinatawag tayo elastic deformation stage. Dito, the strain is reversible. Pag nag-apply ka ng stress, madideform yung bato, pero pwede pa siyang bumalik sa dati niyang itsura or sa dati niyang shape. Pangalawa, we have ductile deformation stage. Pagdating dito, yung stress or yung pagbabago sa bato ay permanente na. The strain is irreversible, however, the rock is not yet breaking. Pwedeng na-stretch, pwedeng lumobo, pero hindi pa nababasag yung mga bato. At ang pangatlong stage is the fracture stage. Dito, kagaya ng ductile deformation stage, the stress is permanent. It's irreversible. Hindi na mababalik sa dating itsura niya yung bato. But the difference with ductile deformation stage is that rocks break during fracture stage. Kanina, sa ductile deformation, pwede ma-stretch, umangat yung mga bato, matiklop, nang hindi napapasag. Sa fracture stage, dito, magsisimula ng magbitak-bitak yung mga bato. Nakita natin sa diagram na habang tumataas yung stress, nagbabago yung strain. If you increase the stress, unang stage na mararanasan ng bato is the elastic deformation stage. Again, kaya niya pang bumalik sa dating itsura. If you add more stress to it, dadating na siya sa ductile stage na permanente na yung pagbabago, pero hindi pa nagbe-break yung mga bato. Pagdating ng fracture stage, more stress to the rocks. Dito na magsisimula mabasag yung mga bato, and definitely, the change is irreversible. Now, the deformation of the rock is affected by the type of the behavior of material. We have what we call elastic materials or elastic rocks, and we have inelastic rocks. Elastic rocks are materials that return to its original shape once the stress that deforms it is removed. Dito, yung mga klase ng material na to, kahit na gaano katindi yung i-apply mo na stress or pressure, babalik at babalik so sa dati. For the materials in the cross, they are inelastic. So once they are deformed, they cannot go back to their original shape or position. May dalawang klase rin ng inelastic material. We have brittle and ductile material. The brittle material respond by breaking or fracturing. Maiksing-maiksi lang yung time niya for the ductile stage at nababasag agad. That's what we call brittle materials. And you have the ductile material. Ito naman, napakahaba ng ductile stage ng material na to. And it will take a really very long time and a lot of stress before it will break. Brittle materials are commonly found on the upper surface of the earth, while ductile materials are found deep within the crust of the earth. Ano yung mga factors na pwede maka-apekto sa behavior ng isang material? First, temperature. Second, the confining pressure. Remember, kanina confining pressure is an example of uniform stress, the downward force applied by the confining rocks, mga rocks na nasa ibabaw ng bato. Pangalawa, strain rate, yung bilis ng pagbabago ng appearance ng material. Gano'n siya kabilis mag-deform. And pangatlo, the type of materials and their composition. In terms of temperature, at high temperature, molecules and their bonds can stretch and move, thus the material will behave in more ductile manner. For example, yung glass, para ma-change mo into different shapes yung glass, kailangan mo siyang itapat sa napakatinding heat. If you have seen videos, yung glass making, di ba, nag-form sila ng iba't ibang shape, iba't ibang images using glass, kailangan nilang itapat sa sobrang tinding init para madali nila ma-stretch, ma-deform yung glass at hindi ito napabasa. At lower temperature, the material tends to become brittle. Kapag sinubukan mong gawin yon sa malamig na glass or at room temperature na glass, try mong hilahin, pukpukin, or apply ng pressure, na-break apart agad yung glass. Ganon din yung sa rocks. At high temperature, they are more ductile. At low temperature, they are brittle. So yung mga rocks na nasa ilalim, mas malapit sa magma chamber, mas malapit sa mantle, they tend to have high temperature. They are more ductile. While the rocks on the surface, it's exposed to atmosphere, it's exposed to lower temperature, they are brittle. The second factor is confining pressure. At high confining pressure, materials are less likely to fracture. Therefore, they are ductile. So kapag naipit masyado yung rocks, they are pressurized by the downward force of the rocks above them. Hindi sila masyadong nakakagalaw at hindi sila masyadong nagbibitak-bitak. Pero yung mga materials na mas exposed, walang masyadong nakabatong sa ibabaw nila, they tend to become brittle and they fracture sooner. Mas mabilis silang mabasag. That's why the rocks on the surface tend to undergo fracture faster than the rocks found deep within the layers of the crust. In terms of strain rate, this is the amount of change that happens per unit time. At high strain rate, the change is fast. Therefore, material tends to fracture. At low strain rates, the change is slow. More time is available for individual atoms to move. Therefore, ductile deformation is favored. Mas nakakapag-adjust yung mga particles ng rocks at low strain rate, kaya hindi sila agad-agad nababasa. And ductile behavior is what we can observe in those rocks. In terms of composition, some rocks are naturally brittle, like quartz and olivine. And then, some material tends to become more ductile. It includes clay materials, clay minerals such as calcite. The chemical bond in mineral also affect this brittleness and ductility of rocks. The mineralogical composition, commonly if materials are composed of metals, they are ductile. While if materials are composed of non-metals, they tend to become more brittle. Isa pa sa makaka-apekto sa composition is the presence or the absence of water. Addition of water to the rocks make them behave in ductile manner, while dry rocks are brittle. Diba? Kagaya ng clay, kapag medyo mas maraming tubig yung clay, mas madali siyang nade-deform. Pero kapag nag-dry up na yung water sa clay, mas madali siyang napabasag. Hence, it becomes brittle. This graph shows us the behavior of brittle and ductile materials. Brittle materials have longer elastic stage, shorter ductile stage, and it easily reaches fracture stage. While for ductile materials, maiksi lang yung elastic stage nila, pero ang haba ng kanilang ductile stage. That's why they do not break immediately bago pa sila makaabot ng fracture stage. For materials to become brittle, kailangan mababa ang temperature, mababa ang confining pressure, at mataas ang kanyang strain rate. For materials to become ductile, kailangan ng high temperature, high confining pressure, at low strain rate. What are the effects of deformation of rocks? First is the formation of joints. These are natural cracks on the surface of the earth. Dahil cracks, nagpamasag-pasag yung mga bato, the type of deformation is brittle deformation. And the type of stress applied on the rocks to cause joint is tensional stress. This is how joints look like. Ayan, nakita nyo una, flat yung surface, pero unti-unti siyang nagbe-break, nagkakaroon ng cracks kasi napupull away yung rocks away from each other. And since the rocks are on the surface, there is low pressure, low confining pressure, low temperature, and high strain rate. Kaya, brittle deformation na nangyayari. The second effect is the formation of folds. Folds are contortions on rock layers forming wave-like curves. So this is an example of ductile deformation. When rocks are being compressed, so compressional stress yung na-apply, the rocks do not break but form curves or contortions. And this is how it looks like. Yan. So may mga nagkakaroon ng depression and elevation on those rocks. Okay, permanent yung change niya, but the rocks don't easily break kasi nga this is a ductile deformation. And the type of stress is compressional. Naiipit yung bato towards each other, kaya unti-unti silang tumitigilok at nagkakaroon ng curve-like appearance. Ito yung dahilan kung bakit meron tayong mga bundok, meron tayong mga valleys and plains, may high and low part sa surface ng Earth because of the formation of folds. Third is faults. Just like joints, this is an example of brittle deformation. But instead of breaking on the surface, the rocks break on a planar structure, pababa. Okay? This is cause of the sliding of rocks. And yung faults, pwede siyang dahil sa tensional stress, compressional stress, or shearing stress. Kapag hindi na kinaya talaga ng bato, no, yung stress na na-apply because of the compression, the stretching, and the sliding of the rocks, it will eventually break on planes. At dito sa fault, nagkakaroon ng earthquake. Dito nagmumula yung epicenter ng earthquake. And lastly, we have metamorphism. In this case, the rocks do not break. They do not deform. However, the grains or the crystals in the rocks tend to rearrange, change shape, or form another type of mineral. And this leads to the formation of new types of rocks called metamorphic rocks. To sum it up, stress is the force applied per unit area, and this is the one that causes strain or deformation on rocks. Strain refers to change in rocks due to the different types of stress. It is also known as the deformation per unit area. There are two types of stress. We have uniform and differential stress. And differential stress have three types, which are tensional, compressional, and shear stress. There are three stages of deformation in rocks. We have elastic, ductile, and fracture stage. In elastic stage, the rocks can still go back to their original shape or appearance. In ductile, the change is permanent but there is no breaking. And in fracture, the change is both permanent and there is breaking on the rocks. We also have two types of deformation, ductile deformation and brittle deformation. Ductile deformation has longer ductile stage and it will take more stress before fracture happens, while brittle materials have shorter ductile stage and fracture happens faster. Factors that affect deformation of materials are temperature, confining pressure, strain rate, and composition of material. The effects of deformation are joints, folds, faults, and metamorphism. At this point, what we are going to talk about is the metamorphism of rocks. This is one of the effects of the stress or pressure that the rocks experience. However, it is not only pressure or stress that causes metamorphism. Metamorphism is the process that occurs when the rocks change its form into a new type of rock without undergoing melting or disintegration. And in the process, it forms a rock called metamorphic rock. The size, shape, and arrangement of grains in rocks may change, and that is what we call physical metamorphism, or new minerals may grow from the old rocks. That's what we call chemical metamorphism. The original rock before it undergoes metamorphism is called protolith. And the type of metamorphic rock may vary depending on factors like temperature, pressure, chemically active fluids, and the parent rock. During the first quarter, we discussed that there are two types of metamorphism, regional and contact. But this time, we are going to add 4 more because they have more specific processes. Regional, contact, and hydrothermal, as well as cataclastic or dynamic metamorphism, are all endogenic in nature. While burial metamorphism is a combination of exogenic processes and endogenic processes. Shock metamorphism is exogenic, even extraterrestrial in nature, and we'll find out later why. First, we have regional metamorphism. If you can remember last quarter, this is the change in the appearance of rocks due to the pressure and convergent plate boundaries. So if we're going to relate it with stress, the type of stress that is applied on regional metamorphism is compressional stress. It occurs due to the pressure and heat applied to the rocks by converging plates and the building up of mountains. This type of metamorphism produces large amount of metamorphic rocks. And the factors that affect regional metamorphism are high pressure and high temperature, but low water content. The second type of metamorphism is contact metamorphism. If you can remember, during the first quarter, contact metamorphism is caused by the immense heat by the presence of a magma nearby. It occurs due to the heating of country rocks by the rising magma. Remember last week we talked about magnetism, and as the magma rises up, it heats the rock that it will pass by or pass through. Habang dumadaan yung magma na yon, naluluto niya, no? It's somehow baking the rocks and causing them to change in chemical composition, change in mineral structure, and so on. So that causes metamorphism. That's what we call contact metamorphism. In this case, the factor that affects the metamorphism of the material is the presence of high temperature. There is no added pressure, unlike in the regional na nako-compression rocks. Fluids may be present from groundwater reservoir or seafloor in contact metamorphism. And usually, if there is a presence of water in contact metamorphism, nagkakaroon ng chemical change in the rocks and it really has a new mineral composition. Examples of rocks that are changed by contact metamorphism are marble, quartzite, and hornfels. There is also hydrothermal metamorphism from its name, hydro, referring to water, and thermal, referring to heat. This is caused by hot fluids, commonly water. The presence or the addition of hot fluids promote recrystallization. This is the change in size and shape of minerals. Or it may also cause neocrystallization. This is the formation of new mineral by the chemical reaction with that hot fluid. It occurs in oceanic ridges where divergent plate is happening. It may also happen in subduction zone where plates are converging, and it may occur in groundwater near magma chamber. So sa ilalim ng lupa, may groundwater ka, kumukulo yun kapag malapit sa magma chamber, and that hot water may cause this hydrothermal metamorphism. Examples of rocks that are caused by hydrothermal metamorphism are serpentine and blue schists. So we have here seafloor metamorphism. That's an example of hydrothermal metamorphism in divergent plate and seafloor in oceanic ridges. And we have subduction metamorphism. This happens in subduction zones or converging plate. Other types of metamorphism include cataclysmic metamorphism. This happens in sharing plate boundaries or sharing stress. So when plates are moving past each other, okay, nare-rearrange din yung crystal doon sa ilalim ng mga rocks and minerals. Those rocks and minerals have elastic behavior or plastic-like behavior. Example of metamorphic rocks formed by cataclysmic or dynamic metamorphism is mylonite. We also have burial metamorphism. This is a combination of exogenic and endogenic process wherein rocks are being sandwiched by the rocks on top of it and the rocks at the bottom of it. So the pressure of compression from above and below causes the rocks in the middle to undergo metamorphism. Examples of rocks that are changed by burial metamorphism are metaconglomerates. Again, this is due to the confining pressure of overlying rocks and increasing temperature and pressure at different portions of rocks. And lastly, we have shock metamorphism. It is extraterrestrial in nature because it is caused by the impact of a meteorite. So sa pagtama ng meteorite sa surface, meron yung heat and mechanical energy, and that will cause the rocks to be pressurized and undergo very quick metamorphism. So examples of rocks that are formed from this type of metamorphism are impact. Metamorphic rocks can be classified as foliated metamorphic rocks or non-foliated metamorphic rocks. Foliated metamorphic rocks have minerals that are aligned in parallel layers and form bands. These rocks commonly form flakes when they break. Nafo-form yung foliated metamorphic rocks kadalasan sa regional metamorphism at sa burial metamorphism kung saan natutulak yung mga minerals. Okay, yung pag-push ng mga minerals na yun cause them to realign. Diba? Halimbawa, meron kang mga nakakalat na ballpen. Pag unti-unti mong tinulak-tulak yung mga ballpen na yon, diba, unti-unti silang magpo-form ng diretsong linya. So that simulates how foliated metamorphic rocks. Dahil sa pressure na nare-receive ng grains from the compression of two plates or the burial of rocks, nare-realign at nagkakaroon straight lines at the ends. Pag non-foliated naman, the minerals are randomly oriented and usually have granular appearance. Rocks do not flake in thin layers when they break. Dito naman kadalasan nangyayari ito sa contact metamorphism and hydrothermal metamorphism. These are examples of foliated rocks. Makikita nyo. Etong slate, hindi pa masyadong visible yung kanya. But, pero yung nice, ayan, makikita nyo, no, talagang may mga lines na siya. Yan, yung grains niya ay naka-arrange into parallel line. And we also have sheets. For non-foliated rocks, talagang random lang yung kanyang mga crystals o kanyang mga granules. How does foliation occur? Like what I said, because of the pressure applied on the grains. Let us watch this video for us to see how this happens.
If we see alignment of these minerals in a rock, we call the rock foliated. The extent of foliation, combined with the types of minerals present, can tell us a lot about metamorphic setting. For example, foliation can happen only when a rock is subjected to increasing pressure. Notice this pile of pencils and pens, completely unaligned or unfoliated. As I start to compress this system along one axis, the pens and pencils that are free to move will start to align themselves with each other. The greater the pressure, the greater the alignment or foliation.
Alright, so that's how foliation happens. Because force is applied on those grains and certain axes, they tend to form a straight line and appear as bands on foliated metamorphic rocks. Now, aside from pressure, temperature, the presence of water or fluids, the parent rock also affects the type of metamorphic rock that will be formed. For example, we have this slate, it forms from shale. If shale undergoes regional metamorphism, nag-apply ng pressure sa kanya, it will form a metamorphic rock. Slate. If the slate is exposed to more pressure due to regional metamorphism, it may transform into phyllite. Phyllite, if it experiences more pressure, it may transform into schist, and schist, adding pressure to it, may transform into gneiss. But if you increase the pressure on gneiss, it will start to melt and form magma. For marble, the parent rock is limestone or dolostone. It can never be formed from any other parent rock aside from these two. Quartzite is formed from quartz sandstone, and anthracite is formed from bituminous coal. So this parent rock is very important as a factor in the formation of metamorphic rocks. Again, we call these parent rocks as protoliths. There is also what we call metamorphic rock grading. This happens especially in metamorphic rocks formed by regional metamorphism or foliated rocks. As you increase the pressure, there is an increase in metamorphic grade, then the bands, the foliations are becoming more visible. So this metamorphic rock grading is affected by the increase in pressure and increase in temperature. As you add more pressure, as you add more temperature, tumataas din yung metamorphic grade. For foliated rocks, mas nagiging visible yung kanyang mga bands. Summarize, metamorphism is the formation of new rocks affected by factors such as pressure, heat, addition of fluid, and parent rocks. We have several types of metamorphism. There is contact metamorphism due to the contact with heat of surrounding matter. Regional metamorphism due to the pressure of converging plates. Bureal metamorphism due to the confining pressure of overlying rocks. Cataclasic metamorphism due to the shearing of plastic-like rocks near the fault line. Hydrothermal, which is caused by the addition of hot water. And shock metamorphism due to the pressure brought by the impact of a terrestrial object, commonly a meteorite. The two types of metamorphic rocks are foliated and non-foliated rocks. I hope that you learned the lesson for today. Did you understand it? If so, that's the end of our discussion, and I will see you again next week. Thank you and goodbye.